Hi, and welcome to this module on iterators in Q. This is our sixth module in the Fundamentals series, so please feel free to check out the previous modules if you haven't already. So we very rarely write loops in Q. Instead, we use iterators. And if you're coming from another programming background, this can take people a while to grasp and get used to at the beginning. But it's a key feature of array-based languages like Q, so it's important to understand. So we'll start today by looking at what are iterators and then some inbuilt iteration and how that works. And then we move on and look at our mapping iterators. And we've already seen one of these, which is each. And we'll take a look at that in more detail. And we'll also look at the other many varieties of each we have to use. Okay, let's get started. So what is iteration and what are iterators? So iterators were previously known as adverbs. So you might see that terminology used in other documentation. And what they do is modify the behavior of a function, and they will apply a function iteratively, so hence the name iterators. And this replaces the use of loops as commonly seen in other programming languages. So before we look at our explicit iteration, let's look at some of the inbuilt iteration available to us. So Q actually does iteration for us natively when we use primitives. So in this example, you'll see we have two lists, 1, 2, 3 and 2, 3, 4. So they're both of length 3. And if we add a plus in the middle, what happens is Q understands that you want to add these pairwise, which means you want to add the first and the first element of both lists, the second and the second, and then the third and the third. And then in the second example here, when you have a scalar or a singular value on one side and then a list on the other side, Q understands that you want to add that to each of them. So 2 times 5, 2 times 6, and 2 times 7. So you see we didn't need to use any loops there. Q automatically for us is doing iteration. Now when we run into trouble is when we have lists with different lengths. So in this example here, you'll see I have a list on the left of length 2 and on the right of length 3. And when I run this, I get a length error. And this is because there's ambiguity around this. Q isn't sure what you're telling it to do. Are you telling it to add 2 to each on the right, and then 3 to each on the right, or the other 4 to 2 and 3, 5 to 2 and 3, 6 to 2 and 3. So when there's ambiguity involved, you're going to get an error. So how do we work around this? So we can modify this using a mapping iterator in order to do this operation. So just a quick summary into all the mapping iterators that we have available to us. So we'll look at each to start with, and then we move on and look at parallel each. Then we've got each both, each left, each right, and each prior. So you see some of them, each here and each are just keywords, whereas the last 4 here are characters. So it might look a little scary, but we'll get into each, pardon the pun, and break them down. Okay, so first of all, each. So we've seen this in our previous modules, and let's take an example of how we might use this. So first of all, we've got this list of lists. So if we run this and we have our show out in front and we count it, you'll see I've got 4 sublists within the list. And if I count that, I get my 4 returned. Now, if I wanted to modify count, so count is my primitive in this example, I can use each in order to do that. So I'm counting each sub-element in the list. So you see 3 is returned from the first count. So 1, 2, 3, and then I've got 2, 1, 2, 1, 2, 3, and then 1. So it's fairly straightforward. I can also apply other monadic functions to each iterator. So for example, with type or with the keyword reverse, we're able to use each to apply that to each element of the list. So getting type of each L returns the type of each of these. And then reverse each L is going to reverse each sub-element. And the point here to note is that these are monadic functions. So count, type, and reverse all take 1 parameter. So remember, we learned about monadic versus dyadic. So with monadic functions, we just simply take 1 parameter. With dyadic, it's 2. And that's important when we need to use iterators. Okay, so just showing here with each, we can also apply it functionally. So instead of saying average each L in this example, we're doing each and then passing average, the function average here with the list L. So if we want to use that bracket or functional notation, we can. Above here is known as infix. Okay, so the point on monadic versus dyadic is you can't simply use each when the function takes more than one parameter. So for example, the function in, we're applying it here. So 3 in 1 and 2 will get a 0 because it doesn't exist. Then 3 in this list here, it does exist. And then this is me just applying it functionally. So is 3 in this list here? And I'm getting a true. Now, if I try and create a list of lists and use 3 in each, I get a parse error. So in order to get around this, we can project the function. So for example, here I'm creating a projection here, so 3 in, and I'm saving that to the name of the variable is 3 in, and then I can apply that across my list. And then if it's a projection like this, I'll be able to use the keyword each across that sample list. So you see for each list, I'm getting a true or false returned. We just got a little note here. Since each applies functions to every argument within a list, aggregate functions like max, which return atomic values, so singular values, will return lists of atomic values when they are used with each. So it will look like something like this. Okay, so we've got 2 short exercises here on each. So have a go at those, and I'll see you in the next video.